Welcome to today's Central Region Guest Speaker Series. I am Andrew Just from Central Region Headquarters STI, and I will be facilitating today's talk. As a reminder, this meeting is being recorded. If you have any questions during this presentation, please feel free to hold on to them until after the talk, or post them in the chat and we will answer them at the end. With that, let me introduce today's speaker, Ben Herzog, who's the SU at the National Weather Service in St. Louis. Ben did his undergrad at Mizzou and grad school at Oklahoma. While in school, he was a student volunteer at St. Louis and a Holland Scholar at the Weather Service office in Melbourne. After school, he spent 6 months with SIMS and NSSL before starting at the Weather Service in Milwaukee. And there he spent 4 years as an intern and then was brought on as a general forecaster at St. Louis in 2018. After a year, he was promoted to a lead and started again as a SU about 2 months ago. With that, I will pass it on to you, Ben.
All right, thanks, Andy. Obviously, here we'll be talking about some tornadoes that we had come through St. Louis getting close to about a year ago now. This is kind of an expansion of the talk that I gave at the Severe Storms and Doppler Radar conference about a month and a half ago. So for those of you that sat through that one, sorry, this is going to look pretty similar to what you saw then, but there's a little bit of extra information in there as well. So with that, I'll go ahead and get started here. So here's kind of of course it's not looping now. Let me try to get this started one more time. Well, that's fun. I promise it's supposed to be a loop of the event coming through. Let me try one more thing. Sorry about this. There we go. It seems like when I let it sit for too long, the loop just decides it doesn't want to loop anymore. Okay. So you can see here we had a couple of rounds of thunderstorms that day, and what actually happened is there was an MCV that kind of started in over southeastern Colorado late in the evening of May 18th. It then scooted along the kind of Kansas-Oklahoma border overnight before it moved into southwest Missouri in the morning of the 19th. You can see for kind of eastern Missouri and western Illinois, we basically had 2 rounds of thunderstorms. Actually, both rounds were severe. The first one a little bit less so. We had one report of a measured 58-mile-an-hour gust, and we just had some sporadic minor tree damage, a handful of severe thunderstorm warnings and things like that. Round 2 is where things definitely got interesting for us. That came through in the afternoon. We had 9 tornadoes. 2 of those were EF1, and we had 7 EF0s. We also had numerous reports of tree damage, a little bit more significant tree damage with the second round as well. Let me hit that full screen for you. Taking a look at some of the reports, you can see they extended pretty much right up Interstate 44 from Springfield, Missouri, right through St. Louis, a little bit south of St. Louis and over into Illinois. You can see we did have a lot of straight line wind damage. You can see a handful of tornadoes showing up in there, some hail, and some flooding as well. Taking a look a little bit more closely at the tornadoes, you can see we're 9 of them laid out. Yeah, you can see we had actually 4 EF0s in St. Louis County itself, right in the middle of the map here, along with a handful of other tornadoes. And then I guess, fortunately, the 2 EF1s were about as far from the metro as any of these other tornadoes were. So that probably would have been a worse result for us, obviously, if it was in those more highly populated areas. So quite a bit of tornadoes, but if you look at how we performed, it definitely left something to be desired. You can see a number of these tornadoes were unwarned, and the lead time on most of these tornadoes were kind of well below what we're striving for. And so, you know, obviously, we're trying to look for opportunities that we can improve here. Just looking at the performance more wholly, 4 warned tornadoes, 5 unwarned tornadoes. Haven't shown so far is we actually only had 2 verified tornado warnings and 6 unverified tornado warnings with an average lead time of about 9 minutes. So obviously that leaves some room for us to improve, and that's kind of what got me looking at this case in the first place anyway, is what can we do to improve? You know, I'm trying not to be overly critical of the office. It was obviously, as you'll see, a pretty complex event, but I think there are definitely some things we could have done to look at this a little bit better and improve when we see an event like this again. In fact, if you go back about 2 weeks ago, we had another event where we actually had 12 tornadoes instead of 9, and we did do quite a bit better. So hopefully we are learning from this. But let's go ahead and take a quicker look now. So I'm going to kind of jump ahead well into the event. This is composite MRMS reflectivity at 18Z. You can see the first round of convection has already moved through St. Louis, and we're going to be more focused on the kind of organizing MCV down over southwestern Missouri. Taking a look at satellite imagery, the 2 hours leading up to 18Z, unsurprisingly, there's pretty widespread cloud coverage across the St. Louis metro and most of our CWA. Another round of very widespread cloud coverage associated back with the parent MCV, but you do see a lot of clearing kind of between the 2 rounds of convection. And so that's going to be kind of a key point as we go forward, is paying attention to what happens there, how much is that going to allow our CWA to warm up, and how that's going to impact the potential for severe thunderstorms. The other thing that kind of stands out to me in this loop a little bit is that the convection over southwest Missouri does appear to be quite a bit more vigorous than what's going on over kind of the St. Louis metro at this time. You can see numerous towers going up kind of all at once as we get into those early afternoon hours. Definitely some intensifying convection there, whereas we're more steady state, if not decaying, over our CWA at this time. The original point of this talk was to do a thorough mesoanalysis, and I am a firm believer that the best place to start a mesoanalysis is a hand analysis. Unfortunately, hand analyses don't really show up very well in this format, and so I'm going to attempt to digitize this a little bit. So I'm going to take the 18Z surface map and do just kind of a very rudimentary surface analysis and see what's going on. So first, we're just going to contour temperature, and unsurprisingly, there is a pretty well-established, I guess we'll call it cold pool, kind of between these 2 rounds of convection, where it's below 70 degrees, kind of up and down Interstate 44 from Springfield to St. Louis. Contour 75 degrees around that, and pretty much the entire rest of the region is 75 degrees. In fact, topping 80 degrees as you get further south. Taking a look at dew point, it paints kind of a similar picture, where our lowest dew points are found again along that I-44 corridor, less than 62 degrees. And as you get further away from that, the dew points unsurprisingly increase. And of note, bear with me one second. No, I'm going too fast. There we go. What I wanted to point out was the 72-degree isodrosotherm that's kind of creeping up the Mississippi River, making its way towards St. Louis. Kind of taking all of this together, obviously we can analyze this outflow that's kind of just south and east of St. Louis associated with this first round of convection. You can see the winds kind of out of the southwest as it's pushing over in Illinois, out of the north as you get just east of St. Louis. So pretty well-defined outflow boundary there. But outside of that outflow boundary, we've got pretty much southeasterly flow across the entire region. So not really any evidence of any type of synoptic boundaries or anything like that. Basically just our outflow boundary here. And then again, I wanted to point out that moisture is advecting in from the southeast. Here's a look at our public messaging that went out about 12 minutes before 18Z. You can see we're talking about round 1 and round 2. And then the threats we're talking about is storms that become severe will be capable of damaging winds, large hail, and tornadoes primarily along and south of I-70. So that's good. We're messaging all hazards. We're talking about along and south of I-70. I'm going to be referring to I-70 an awful lot in this talk. So to kind of zero those of you in that are not familiar with the highways in our forecast area, I-70 runs basically from Kansas City to St. Louis, kind of right through the middle of Missouri. And so along and south of I-70 is basically the St. Louis metro, Columbia, Missouri, and south. And so that's what our public messaging is talking about. And, given that I already kind of showed you what happened, that's probably not too far off base. Here's what we had in our partner messaging at this time. So this was something that we posted to NWS chat, 1831 UTC. And here we're talking about a warm front that developed over southeastern Missouri, where cumulus is developing. Our expectation is that that front's going to drift slightly north. It's going to serve as the northern boundary of severe storms, and our best guess is that the front is going to get somewhere near Crawford, Washington, and St. Francis counties, and those counties are about 50 to 60 miles south of St. Louis. And so there's a couple of things I want to pause here and talk about. First of all, that warm front that we're talking about, we mentioned that it is developing over southeastern Missouri where the cumulus is developing. Taking a look at our satellite imagery at 18Z, you can see the cumulus that they're talking about is really confined to pretty far southeastern Missouri. You take that area and plot it on top of that surface analysis that I did, and I don't see much evidence of a warm front here. You know, we talked about not really seeing much in the way of a synoptic boundary. We just have that outflow. And so my question kind of right off the bat is that a warm front? You know, of course, our temperatures and dew points are warmer across the southern portions of the area, but that's not uncommon, especially this time of year. And there's really no evidence in the wind field that there's a warm front there. And so kind of my first question when I was looking at this is, did we perhaps underestimate the ability for that warmer and more moist air to extend further north? You know, if there was thinking in ops that there was a warm front there, maybe the thought is that's a little bit more of a rigid boundary. It's going to have a harder time advecting north, as opposed to just that outflow boundary that can kind of, you know, come and go with the winds a little bit easier. I wonder if we underestimated the ability for the warmer and more moist air to extend further north, and therefore for the severe weather threat to extend further north. The other kind of concerning thing that stood out to me is the difference between our public and our partner messaging. In our public messaging, we mentioned that the severe threat is going to be along and south of I-70, including St. Louis. Our partner messaging that went out roughly the same time said that the severe threat is going to be roughly 50 to 60 miles south of I-70 in St. Louis. And so to me, it seems to me that that inconsistent messaging may reflect inconsistent expectations and operations, which is obviously not something that we really want. We really would like everybody to be on the same page. And so I unfortunately was not in the office this day, so I don't know exactly what the dynamics were, but that's just kind of how it looks to me from the outside looking in. All right, we're going to fast forward to 21 UTC. You can see our first round of convection is well to the east of the area. The MCV has developed into a pretty well-defined quasi-linear convective system, and it's in our CWA at this point, and it is approaching the St. Louis metro area. Another look at the satellite imagery, you can see that the clouds really cleared out between these two rounds of convection. We've just got ample insulation ahead of this QLCS. So we're thinking the instability really should be rebounding pretty robustly in the wake of that first round of storms. Going to do another surface analysis here, and indeed you can see that isotherm, the 80-degree isotherm, extends well into the St. Louis metro area, so plenty of warm air is coming in, and then of course much cooler air back behind that QLCS. Dew points show kind of a similar story. If you remember the previous dew point analysis, that 62-degree isodrosotherm was along Interstate 44. It is pushed well north into kind of central Illinois. Much of our CWA is in excess of 68-degree dew points, and we've actually got that 72-degree contour also kind of riding up the Mississippi River, moving into the St. Louis metro. In fact, temperatures and dew points around St. Louis have surged about 5 to 10 degrees in the last 3 hours, and there's that kind of dew point surge you see there. In fact, if you look at the SPC meso analysis and look at the 3-hour temperature change, indeed, we've actually got a 6-degree contour pretty much right on top of St. Louis. And you look at the 3-hour dew point change, and our dew points have increased about 4 degrees. So as you would expect, our instability has really rebounded quite a bit. Here's a look at what the ML Cape did between 18 and 21 UTC. You can see we're easily in excess of 1,000 joules per kilogram of ML Cape over the St. Louis metro, with at least 2,500 joules per kilogram just upstream. Not shown here, our effective bulk shear is 25 to 40 knots, so you can understand why we had some concerns for severe weather in the first place. And it does seem like it's really kind of impinging upon the St. Louis metro. The other thing I want to point out is the very strong gradient we see in the instability field here. You know, it's been noted numerous times that you know, those gradients are where interesting things tend to happen. And so that's another thing that kind of has my attention coming into this event. And then, trying to figure out, all right, why is this instability rebounding like this? Well, if you remember what those dew points were doing, kind of surging up the Mississippi River, the ML Cape really reflects that same trend very clearly, where you've got those higher values of instability really just riding right up along the river into the St. Louis area. Slightly different look at Cape here. Here's the 0 to 3 kilometer ML Cape, and we've got at least 100 joules per kilogram of 0 to 3 kilometer ML Cape moving in from the southwest. And so that tells me that anything that does get going in the lowest levels is going to have access to kind of ample instability to really intensify quite rapidly. And again, note how tight that gradient is right on top of St. Louis. So that's another kind of concerning thing to me, is we see this gradient, we see where these, quote unquote, interesting things are going to happen. And again, looking more and more like St. Louis may be right in the crosshair of whatever's going to happen here. Thinking about why this is kind of evolving like this, let's flip over to our back to our visible satellite loop. And it seems to me that kind of bullseye of the highest 0 to 3 kilometer ML Cape is just kind of coming right up with that clear slot. Just all of that insolation, all of that sunshine really helping make things unstable in the lowest levels. And so again, it seems like, just looking at this information, St. Louis may be a kind of a point of interest as we go forward. Taking a look at our messaging now, this went out at 3:29 p.m., so about a half hour before any of that information that I just showed you. But you can see our public messaging has changed a little bit. We've got kind of two areas of concern here. Mainly south of St. Louis, we're talking about higher chances for damaging wind, hail, and tornadoes. And then to the north and kind of that yellow contour, we're talking about a medium chance for damaging winds, hail, and tornadoes. So it seems like now our public messaging has come into line with what we were sharing with our partners 3 hours ago, where the greatest chance for severe is going to be south of St. Louis. In terms of our partner messaging at this time, we didn't really say much on NWS chat about our expectations going forward, because we were already actively issuing warnings. And so there was just a flurry of activity talking about what's going on with those warnings. However, in our AFD, we did discuss it. We mentioned that the MCV is going to track east across the southern portion of the forecast area early this evening. And so, I'm not going to read the whole thing here, but again, our partner messaging is still focusing kind of on the southern portions of the forecast area. So it's good news that our both kind of sides of our messaging, our public and our partner messaging is in lockstep now. But now my question is the threat really less over the I-70 corridor and into St. Louis? And again, just throwing these loops of instability back up, I'm beginning to think that that's probably not the case. Those pretty high instability values are making it into St. Louis. And so I'm thinking that our threat might be further north than what we're messaging. One other mesoanalysis field that I've not shown yet is 0 to 3 kilometer wind shear. You can see here it is in excess of 30 knots. It's out of the southwest. And actually, what I don't show here is the MCV, kind of the cyclonic flow around that seems to be really enhancing the low-level wind shear anyway. And so as it approaches the St. Louis metro, these 0 to 3 kilometer wind shear vectors are actually on the ramp up as well. So hopefully by me showing the 0 to 3 kilometer wind shear vectors, that got some gears turning for those of you listening. And we're going to talk about the QLCS mesovortex warning system. There are kind of 4 steps to that warning system, and we're going to talk about all 4 of them, but I just got the first 3 listed here. And that's to identify the 3 ingredients, identify our confidence builders and nudgers, and choose the appropriate warning based on the quantity and quality of those confidence builders and nudgers. So at this point, we're going to transition a little bit from a kind of a mesoanalysis talk to a little bit more of a radar analysis talk, mainly because I can't help myself but to show radar imagery and talk about QLCSs. So that's what we're going to do. So taking a look at the radar from our office, you can see at 21 UTC, QLCS is well into our forecast area. Our 0 to 3 kilometer shear vector is basically completely perpendicular to the updraft downdraft convergence zone, 30 to 35 knots. So we know we've got one of our 3 ingredients met already. And in fact, you can see this whole thing is pretty much bowing. So there's 2 of our 3 ingredients. And now we just need to determine whether or not our updraft downdraft convergence zone is balanced or slightly shear dominant. Before we do that, though, the other thing I wanted to point out is note the convection that's ongoing ahead of the QLCS. it doesn't show up super well here, but these two are actually little supercells. And this storm kind of immediately north of the QLCS is actually about to produce a tornado. That's our first tornado of the day came from this storm. And that was actually one of our EF1s. And so the fact that the environment out ahead of this QLCS is supporting these small supercells really tells me that the environment that the QLCS is moving into is going to be quite favorable for convective development. So we're going to zoom in a little bit. I'm going to do kind of a quick and dirty radar analysis on this first part of the storm, and then we'll look at it a little bit more closely as it moved into St. Louis. What I've got highlighted here with the white dashed line is our updraft, downdraft convergence zone. And you can see for a large portion of the QLCS, we are indeed balanced or slightly shear dominant. As I mentioned, there are several portions of the line where we've got at least 30 to 35 knots of line normal, 0 to 3 kilometer shear, and the whole thing basically at this point is really surging. You can see on the backside of the reflectivity some pretty substantial dropouts indicative of our descending rear inflow jet. You can see little segments of the line that are kind of the updraft downdraft convergence zone that are kind of an enhancing area, especially this kink kind of right at the apex of the bow. And as I mentioned, our 0 to 3 kilometer cape is in excess of 40 joules per kilogram. So kind of right off the bat here, we've already got, obviously our 3 ingredients are met. We've got 3 of our confidence builders and 4 nudgers. And so we've already got pretty compelling evidence that we ought to be issuing at the very least a severe thunderstorm with a tornado possible tag, but more probably just go right into a tornado warning at this time. And then actually looking a little bit more closely, you can see where that sort of kink at the apex of the bow is at. We already have a mesovortex with a rotational velocity of 25 knots. And so if we were on the fence at all about severe versus tor, I am absolutely ready to go with a tornado warning at this time. So this is at 2108. We're going to go forward about 10 minutes, and wouldn't you know it, we've got a tornadic debris signature associated with that mesovortex. So this is actually our second tornado of the day. Not shown again was that tornado with the supercell just to the north of this line. And so we've already got a QLCS that's got a history of producing tornadoes. And so if you're paying attention to the QLCS mesovortex warning system, that's another nudger of ours, is a history of producing tornadoes. So we're going to fast forward now as the QLCS is moving into St. Louis, again, to kind of orient you with the geography of our CWA. St. Louis is pretty weird. St. Louis City is its own entity. It's not part of St. Louis County. And so that's what this shape is here, is St. Louis City. We've got St. Louis County over here. Jefferson County is down here. St. Charles County is here, and that's where our office is. Pretty much all these counties that I mentioned are pretty densely populated, especially as you get in closer to the city. And so we are definitely moving into our most populated portion of the forecast area. So here's what the QLCS looked like at 2129 UTC. And then we'll fast forward 10 minutes to 2139 UTC. And what I want to draw your attention to are the portions of the line just on the backside of the updraft downdraft convergence zone. You can see in these 2 highlighted areas that reflectivity really has dropped off in the last 10 minutes. That is indicative, again, of our descending rear inflow jet. So that's one of our confidence builders. Looking at the same portion of the line, same time periods, just looking at a different radar moment and different kind of orientation to my slide here, I want to highlight the updraft downdraft convergence zone, specifically right here. And you can see there's quite the pivot to the UDCZ there, and that is our enhancing surge or bow. So that's another one of our confidence builders. So getting back to kind of this, I guess, cheat sheet, I'll call it, that I've put together. Obviously our 3 ingredients are met. My white arrows there are 0 to 3 kilometer shear. I already highlighted our descending rear inflow jet, our enhancing surge and bow. And again, we've got our 0 to 3 kilometer ML cape in excess of 40 joules per kilogram. Clearly, we've got some cell mergers going on with that convection that's developed out ahead of the QLCS. And as I mentioned, this storm at this point does have a history of tornadoes. We had that one, TDS that I showed you. We had the other TDS, not necessarily from the QLCS, but from that supercell. So again, just indicative that the environment is capable of producing tornadoes. So the last step of the QLCS mesovortex warning system is to draw your warning appropriately. Well, I guess I kind of jumped the gun here. If it's not clear, I'm going tornado warning at this time. We've got 5 confidence builders and nudgers, so that puts me solidly, comfortably into the tornado warning decision. So when it comes to drawing your warning, there's kind of a lot that goes into that, and I actually wanted to take a moment here to put in a plug for the latest, well, I guess it will be soon to be the latest SWIP release for the Convective Warning Improvement team. We'll be releasing a polygonology video specifically for QLCSs. We're reviewing that right now, and it should be released relatively soon. But the polygon that I've got drawn here follows pretty closely to much of the guidance provided in that video. You can see I am trying to pay attention to county boundaries and things like that. But I'm also making sure that I'm capturing kind of all portions of the line that we're concerned about. So much of this line is orthogonal to our 0 to 3 kilometer shear vector. This entire portion of the line is either balanced or slightly shear dominant. It's surging. We've got all these other features that I spoke about. And so I just went ahead and issued a relatively large tornado warning, and that's what you're going to see with these QLCSs if you're following the mesovortex warning system. You know, arguments could be made that maybe you could leave out kind of the southern portion of St. Louis County, or perhaps the southern portion of St. Louis City. But to me, that's just cutting a little bit too closely. Another thing that I keep in the back of my mind, just knowing how our counties kind of react to tornado warnings, if we issue a tornado warning for any part of St. Louis County, the sirens are going off everywhere. So I'd like to avoid splitting, especially St. Louis County in tornado warnings if I can help it. That's obviously not always going to be the case, but this seemed to be an instance where it was probably pretty helpful to include the entire county there. So that's an example of kind of what my tornado warning would look like as the storm is moving into the heart of the St. Louis metro. Here's a loop of our storm relative velocity and correlation coefficient. And if you look closely, you can see at least 3 of the TDSs. The first one is going to be down here in one of our southwestern kind of suburbs called Eureka. There's a TDS down there. And then there's actually another TDS that pops up right in the heart of St. Louis County, right there. What I mentioned earlier that I was not in the office because I was on midnight shifts for this day. And I actually woke up to WIA. I looked at the radar very briefly and said, we're fine. And then the next thing I know, this TDS is, you know, about a mile from my house. And so that was kind of an interesting wake-up call that day. But actually, if you zoom in, you can see 4 mesovortices all lined up right through the heart of St. Louis County. And so it was pretty prolific, at least mesovortice producing QLCS, and it really did produce quite a few tornadoes, albeit relatively weak tornadoes, fortunately. So that one warning that I issued, it would have detected all 4 St. Louis County tornadoes, and it would have also improved the lead time by about 15 to 20 minutes compared to what we did. I didn't show what we did, but as you could probably surmise based on some of the information that I gave right off the top, we didn't follow the mesovortex warning system probably quite as well as we could have. In fact, most of our warnings were relatively reactionary. I mentioned the first TDS was down in southwestern St. Louis County. At that time, we did not have a tornado warning out, and so we got one out as soon as we saw the TDS. But it seems like we maybe didn't quite have the time to fully apply the mesovortex warning system, and so we kind of scattershot our tornado warnings across the county. I think we ended up with like 4 tornado warnings on this portion of the storm alone. And so clearly using the mesovortex warning system to kind of anticipate where those mesovortices were going to develop resulted in much more favorable results than trying to sharpshoot the mesovortices as they pop up. So kind of summarizing everything up, there's really nothing earth-shattering here, but again, it was an event that we didn't do as well as I would have liked, so I really wanted to take a more in-depth look at. But really my takeaway points here are a thorough meso analysis is critical. I think if we were looking a little bit more critically at some of those fields that I had shown in this presentation, we may have been more prepared for the QLCS to move into St. Louis. I think that's probably another reason that our warning performance was below what we would like it to be, is because we just weren't anticipating that type of severe storm to make it as far north as it did. And then, of course, expert application of the QLCS mesovortex warning system would have improved our warning performance. And hopefully I was able to demonstrate that pretty clearly. And so that is all that I've got. I'll go ahead and wrap it up, and I'd be happy to take any questions. Thank you.
Yeah, thank you, Ben. First off, I do want to ask, are there any questions out there from everyone? Well, while we wait, again, thank you for presenting this case today. First off, I really like how you went back over this event, trying to figure out how to improve. I know that it's not easy sometimes to do this in operations, but it's needed, even if the events go well. It's also a nice case here presented with rapid air mass changes. I know these rapid air mass changes ones are often result in some bad things happening. So, and also perfect timely review of the QLCS mesovortex warning system as we continue marching here through convective season. We got a question here, Matt Walters. For the long track EF1 in Southern Illinois, was that still within the QLCS?
It was, yeah. That was definitely the strongest and most long-lived tornado we had on the QLCS, and just kind of another opportunity to plug the upcoming video that the SWIP's going to be releasing on polygonology. We actually talk specifically about that portion of the QLCS, so stay tuned for that. Hopefully that'll be released in the next few months here.
Related, I was going to say I'm curious about the polygonology challenges here with the supercells ahead of that rapidly moving QLCS, and how do you handle that?
Yeah, it's I didn't take a close look at how the supercells kind of played into that. I had the luxury of looking this in hindsight and only focusing on the part of the storm that I was interested in, and so but you're definitely correct that presents its own challenges. Probably some combination of perhaps including it in the QLCS tornado warning, or maybe extending the warning a little bit further downstream than you would otherwise. Longer warnings could perhaps be an option. But without looking at it real closely, I hesitate to kind of give a definitive answer on how to handle that in this case.
For sure. Yeah, and I was just amazed to see the number of mesovortices on that line, and I'm glad you brought that up and say just do a broader tornado warning and handle that, because these mesovortices are brief. They show up and then they're there for 5-10 minutes and then they're gone.
Well, I mentioned the event that we just had a couple of weeks ago where we had our 12 tornadoes. It did seem like we did a better job of applying the mesovortex warning system. And it was the same deal where we had one portion of the line actually with a supercell in front of it again. That was a pretty prolific tornado producer. And had we tried sharpshooting those mesovortices, we would have been, dead in the water. But fortunately, we were able to kind of take the lessons learned here, apply them, and have much more favorable results. So.
For sure. Frank Alsheimer here chatted and put in the chat. They're always interesting to see how offices deal with polygonology. It seems like it really is a local call. We have differences in our partner preferences, even within our CWA.
Yeah, I know when we started introducing this kind of warning methodology to our partners in either our media workshops or our IWTs, there's definitely some kind of looks of confusion. I know we've got a handful of media partners that really like tighter, more focused warnings, but I think we've had enough events like this where they understand, especially our TV Mets. I'm not so sure about our partner or our core partners that aren't meteorologists, but our TV Mets are definitely kind of getting the understanding that if we try to be too narrow with our warnings, we're going to have events that look more like this. And so it's definitely a conversation worth having with your partners and seeing what they want. But it seems like the more we explain kind of the limitations and the challenges with QLCSs, that they're pretty understanding to this polygonology methodology.
Yeah, you can use the event like this or something to show, hey, do you want us to do one for this, or would you like this?
Yeah,
and
it's not quite apples to apples, because I think we're a little bit flat-footed here too, and that didn't help anything. But yeah, that's a good point.
Any other questions out there? All right, well, I thank you again, Ben, for presenting today. We will have the guest speaker series here returning in a couple weeks. We have one next one scheduled on May 24th, and may get something between then and now. But again, that would be the next one. So again, thank you, Ben, and thank you everyone for attending today.
Thank you.